This is the current equation we get from our last video. Okay, so today we will calculate the saturation current ID sat. So what we will do first, we will multiply by B pinch off. Okay, then divided by B pinch off. The rest will be the same, and then we will simplify the equation. What we will get, G into B pinch off, and we will take common 3, then divided by 3. Then what will happen? This will be 3 multiplied by VDS by V pinch off minus 2 divided by V pinch off to the power 3 by 2. Okay, VBI minus VGS plus VDS divided by 3 by 2 minus VBI minus VGS to the power 3 by 2. Then this V pinch off we can put inside this one, right? Then we can write down G V pinch off divided by 3 to 3 VDS by V pinch off minus 2 VBI minus VGS plus VDS divided by V pinch off to the power 3 by 2 minus VBI minus VGS by V pinch off to the power 3 by 2. Okay, so now we will derive the saturation current. So I think you remember in my last video I derived Hx is equal to square root of 2 into epsilon divided by Q into Nd root over Vbi minus Vgs plus of Vx right, and A is equal to root over 2 epsilon by Q into Nd multiplied by V of pinch off. Here we assume one variable u whose value is hx divided by a. So we can write down hx by a is equal to square root of vbi minus vgs plus of vx divided by v of pinch off. Okay. So now let's see the significance of u and the different values of u. So I think you remember this diagram, right? This is the depletion region diagram and the saturation region. Okay, and we know this is the source side and this is the drain side. Here I write down u is equal to hx divided by a, whose value is square root of vbi minus of vgs plus vx divided by v of pinch off, right? Let's see the vx. This vx term is 0 where? In the source point, right? Vx is equal to 0 at source point. And Vx is Vds where? At the drain point. I think you remember that diagram I draw in my last video about the resistance, and I show the voltage drop from drain to source is decreased. So at drain point is Vds, at source point is 0. Okay, so I just put that one. So here I see the value of Vx can be 0 or can be Vds. By this value we can get the two values of u, that is u1, that means at the source side. So what we need to do, Vx is equal to 0. So we can put Vbi minus of Vgs divided by V pinch off. Okay, and u2 is in the drain side. So we can write down Vbi minus of Vgs by V pinch off plus V of ds, right? I put here the value of Vx is equal to Vds. Okay, so here you can write down Vbi minus of Vgs by V pinch off to the power half. Here also Vbi minus Vgs plus VDS divided by V pinch off to the power half. Okay, so let's just try to see we can replace these two values in our current equation. ID is equal to V pinch of G0 divided by 3, okay, 3 VDS by VP minus 2 VBI minus VGS plus VDS by V pinch of to the power 3 by 2 minus VBI minus VGS by V pinch of to the power 3 by 2. So here you can see we can replace this part with the U2, right? As you see, VBI minus VGS plus VDS by P pinch off. Here also VBI minus VGS plus VDS by P pinch off. So you can replace these two, right? And here you can see this is the U1, right? VBI minus VGS by VDS. Okay, so we can replace this two part. So we need to replace this part. So what we can do? Here you can see U1 is the square root of VBI minus VGS by V pinch off. U2 is the square root of VBI minus VGS plus VDS by V pinch off. So if we do U2 square minus U1 square, what we will get is the VDS by V pinch off. So just replace these values in the current equation. We will get ID is equal to Vp into G0 by 3 multiplied by 3 into U2 square minus U1 square minus 2 into this one will be what? U2 cube minus U1 cube. Okay, and this term Vp into G0 by 3, this term we call it as the pinch off current. So we can write down pinch off current IP is equal to G0 multiplied by Vp by 3. Okay, so let's rewrite this equation. That means ID is equal to pinch off current 3 into U2 square minus U1 square minus 2 into U2 cube minus U1 cube. Okay, so we need to derive the saturation current, then saturation current, right? At, at the saturation point, what will happen? At the saturation, this depletion region will be max, right? That means in the pinch off point. So here the area of the height of the depletion region Hx will be tends to A. Okay. If the Hx is tends to A, then we can write down in the drain side U2 will be how much? U2 will be 1. Why? That U2 is equal to Hx by A at drain side, right? Is equal to A by A is equal to 1. So just replace U2 by 1. So we can write down ID sat is equal to IP 3 1 minus u1 square minus 2 u2 cube, sorry, this will be 1 minus u1 cube. So here IP is equal to 3 minus 3 u1 square minus 2 plus 2 u1 cube. So IP is equal to 1 minus 3 1 u1 square u1 square plus 2 u1 cube. So this will be the value of drain current at saturation. Okay. So now our next part is the transconductance and the drain conductance. Okay. So let's go to the next page. We already know the current equation ID is equal to G0 VDS minus 2 by 3 into 1 by V pinch of VPI minus VGS plus VDS to the power 3 by 2 minus VBI by 3 by 2, right? So first is the drain conductance. Drain conductance is GD is equal to, you can write down delta ID by delta VDS. So that means for this current equation, we need to do the differentiation with respect to VDS. Okay. So let's do the differentiation of ID with respect to VDS. So you can write down delta ID by delta VDS is equal to G0 1 minus 2 by 3 1 by square root of V pinch of this term will be this term this term will be 0. Why this term will be 0? As this is not the function of VDS, right? It's a VGS and VBI. So while we do the differentiation with respect to VDS, then this term will be 0. So we need to just do the differentiation of this part. Okay. So then 3 by 2 square root VBI minus VGS plus VDS. Okay. So we can write down G0 1 minus this 2 2 3 3 will be cut. Okay, and write down VBI minus of VGS plus VDS by V pinch off. Okay, we can write down G0 1 minus 2. So this will be GD. This will be the value of drain conductance. Okay, so this will be drain conductance. Now let's derive the transconductance. So we need to derive transconductance is equal to GM, right? Is equal to delta ID by delta VGS. So we need to do the differentiation with respect to VGS. Here we can see this term and this term is both is a function of VGS, right? So let's start. Delta ID by delta VGS equal to G0. This term will be 0, right? 0 minus 2 by 3 1 by V pinch of, okay, then we can write down 3 by 2 VBI minus VGS plus VDS multiplied by minus 1 as minus VGS, okay, minus 3 by 2 VBI minus VGS multiplied by minus 1, okay. So if we common 3 by 2, this will be half, sorry, okay, this will be half. So if you common 3 by 2, then we will get G0 is equal to minus this 3 by 2 3 by 2 cut, so we can write down 1 by V pinch off, and this minus and this minus, if we take common, then this will be plus, this will be plus, then we can write down square root of VBI minus VGS plus VDS minus VBI minus of VGS, okay. Then just put V pinch off inside this one, and G0 VBI minus VGS plus VDS by V pinch off minus VBI minus VGS by V pinch off, right? So this will be GM. So what is the value of this term? This will be U2 and this will be U1, right? So we can write down GM is equal to G0 into U2 minus U1. So this will be the value of transconductance. Okay. So now we'll say two things. One, we find out GM, the value of GM is G0 U2 minus U1, right? And the another one we find out GD is equal to G0 1 minus U2. GD is equal to G0 1 minus U2. So at linear region we can write down U1 is equal to U2, right? As at the linear region, the depletion region will be constant from the source side to the drain side, right? So the source side U1 is equal to U2. We can write down this one. So we can write down at linear region, the drain conductance GT is equal to G0 1 minus U1, right? And at saturation region, we can write down that U2 is equal to 1. Why? As I already explained that U2 is equal to Hx by A, right? H is in the saturation, and in the saturation region, U is tends to A. So we can write down U2 is equal to 1. So we can write down Gm is equal to G0 into 1 minus U1. So you can see here, at linear region, the drain conductance is GD is equal to G0 1 minus U1, and at the saturation region, transconductance is Gm is equal to G0 into 1 minus U1, right? So we can say the linear region drain conductance is equal to saturation region transconductance. Okay. Thanks for your time. Please do share this concept with your friends. And if you like this video, please press the like button. It is really means a lot for me. Bye bye.